Hello everybody, welcome to my lesson. Today I am talking about a math problem. It's mainly geometry and trigonometry. What I have is an isosceles triangle. Let me draw that triangle. An isosceles triangle, side A, B is equal to side AD. But the way I draw the triangle is that the base is not horizontal, it is tilted. Let me draw a horizontal line. And call this angle theta. I draw another line from vertex A vertically down so that I intersect the horizontal line at an angle of 90 degrees. I call this point E and I call this point C. And this is perpendicular. This vertical line divides the side BD into two parts, and we call the two parts A and B. And I label the two equal sides of the isosceles triangle by the letter R. This is all we are given. So what is the question? The question is to prove an equation or prove a relation we want to prove this relation. This angle theta, sine theta, is B minus A divided by 2 times the square root R squared minus AB. So how do we prove that? Let's start with some cosine law. AC squared this square, let's use this triangle. So this square is r square plus b square minus 2 times rb cosine this angle. Let me call this angle beta. Because this is an isosceles triangle, therefore this angle beta and this angle are the same. So this is also beta. So I have one cosine law. I can use this triangle, also write down a cosine law. Start with r squared now. No, start with ac squared. So this is another cosine law using another triangle. I can use the same triangle, but start with this side, r squared. So let me write another cosine law, r squared this triangle. R squared is ac squared plus b squared minus 2 times ac times b times cosine this angle. So let me call this angle alpha. Similarly, I can use this triangle and start with r squared. Then I need to use this angle, cosine this angle. This is 180 minus alpha. Okay. What is cosine 180 minus alpha? Cosine 180 minus alpha is negative cosine alpha. And the negative changes this sign to positive. So I have 4 cosine laws. Let me call this first one is 1 and 2, and this is 3, and this is 4. Okay. Let's cancel something by doing some addition or subtraction. Let's do equation 4 minus equation 3. 4 minus 3. So r squared cancels. AC squared cancels. So I have Look, 4 minus 3. So this minus that is cancels. A squared minus b squared. This minus that, which is this minus negative, so it's addition. So I have a plus b here. Now I factor a squared minus b squared. Because the left side is 0, I can cancel a plus b now. So this is 0 equals a minus b plus 2ac cosine alpha. What is cosine alpha? Alpha is here. Therefore, this is also alpha. Alpha and theta, the sum is 90 degrees because this is perpendicular 90 degrees. So cosine alpha is sine theta. So I change cosine alpha to sine theta. From this, I can isolate sine theta. Let's see. Okay. I need some space. Let's see. Because I already have done 4 minus 3, so I need 1 and 2, so I can erase 4 and 3. Okay. Isolate sine theta. Sine theta is equal to negative a minus b here. Move this to the other side, it's negative a minus b. Divide by 2ac now. But negative a minus b is just a b minus a. Look, what I want to prove? I want to prove this. They are quite similar, except I have AC here. So what I need to do is to show AC is the square root r squared minus ab. How do I do that? So I do another thing. 1 and 2, I add them together. Okay. So I don't need this. This is exactly this. Okay. So equation 1 plus equation 2. I have 2 AC squared is equal to this plus that, this plus that. So just add these two equations. And then there is a trick, 2r squared. I add I add 2ab. I add 2ab between a squared and b squared. Because I see a plus b here, if I add 2ab, then this whole thing is a plus b perfect square. But I need to subtract 2ab, right? I cannot just add. So add 2ab minus 2ab. And then continue with this term. All right. So this becomes a perfect square. I move this after 2r squared. I just interchange this and this. So a plus b bracket square and minus this. And I see that a plus b, I can factor it out. So I have a plus b minus, this is gone because I factor this out. So it's 2r cosine beta. Am I too fast? Yeah, look, a plus b, I factor out. I have another a plus b left, and this part. So the left-hand side is 2ac squared. Look, I want to show AC is square root r squared minus ab. Look here. Don't look at the 2. AC squared is r squared minus ab. If I can show this is 0, I'm all set. Is this part 0? Let's look at r cosine beta. R cosine beta. I don't have cosine beta here. Oh, okay. Let's draw a line perpendicular to BD. Then what is r cosine beta? Is from here to here, you see? So let's say this is A, B, C, D, E, F, F. F. So r cosine beta is FD. But this is also beta because this is isosceles triangle. So from this part, r cosine beta is BF. 2r cosine beta, I can consider r cosine beta plus another r cosine beta. R cosine beta is this. Another r cosine beta is this. So r cosine beta plus r cosine beta is BD. What is BD? Is A plus B. So this is A plus B. Then this is A plus B minus A plus B. It's 0 here. Therefore, I have this part. From this part, I can cancel the 2. So AC squared is R squared minus AB. So this is AC squared is R squared minus AB. So I have, so AC is square root. Very good. I have proved. I have proved. So that's the end of the proof. Thank you for watching, and I see you next lesson. Goodbye.